Hello students, welcome to Saurabh Sir's classes. Today we are going to solve few advanced statistics based questions. So let us begin with our first question. So here we have our first question, which says a student has to sit for an examination consisting of 3 questions selected randomly from a list of 100 questions. So a student is giving an examination consisting of 100 questions, but he needs to attempt only 3 questions. To pass, the student needs to answer correctly all the 3 questions. So in order to pass the examination, the student needs to answer all the 3 questions attempted correctly. What is the probability that the student will pass the examination if he remembers correctly answer to 90 questions of the list? So we need to find the probability that the student will pass the examination, which means he or she will give correct answers to all the 3 questions that she attempts examination if he remembers correctly answer to 90 questions. So we have a property also that he knows the correct answers of 90 questions out of these 100 questions. So he is attempting 3 questions. So let the events of the correctness of the questions be: A1 will be first question is correctly answered. Similarly, we will have other two, A2 and A3, where we have second as well as third questions is correctly answered. So we have A1 as first question is correctly answered, A2 second question, A3 third question. So what will be the probability of A1? First, let us know what is the required probability of the question. Here check, we need what is the probability that the student will pass the examination. So for passing, all these 3 events should be true, because for passing he needs to give correct answer of all these 3 questions. So correctly answered A1 should be true, A2 should be true, as well as A3 should be true. So and these 3 should be simultaneously true all together. So in probability, what we do when we require more than one simultaneous occurrence of events, we need to multiply them. So as this is first question, we have written probability of A1. What will be the probability of second question? How will we represent? A2, but not, that is not correct. If we write A2, then they will become independent, but you can check, we have total 100 questions, we have total 90 questions whose correctly answer he knows, and we have 3 questions. Each of the question is independent, is dependent on each other, because total number of questions is same. So here we will have probability of A2, given that A1 has already occurred, that A first question is already correctly answered. Then we need the probability of A2, and for A3 we will write same, that is A1 A2, that is A1 and A2 both are answered correctly. Now we need the probability of A3, and we need total probability will be equal to the product of all these 3. So this is what we need. So first let us begin with probability of A1. So probability of A1. Now what is probability of A1? That he is answering first question correctly. So what are the possible options? He has 90 options in which he knows all the correct answers. So he can answer any out of 90, and the total sample space is 100, because total number of questions are 100. So in 90 out of 100 ways he can answer his first question correctly. Then second, we have A2 given A1. So it is given that A1 has already occurred. A1 occurred means first question is already answered. So we are left with 99 questions, and he has answered first question correctly. So the correct answers are remain to be 89. One question is decreased because he has correctly answered it. So the probability of A2 that the second question will also be correctly answered will be 89 by 99, because we have 89 questions whose answer he knows correctly, and total number of questions left are 99. Similarly, question A3, event A3, that is third question, where A1 and A2 both are answered. So he is left with total 88 questions whose correct answer he knows, because he has given 2 correct answers, but he knew only 90 of them correct answers. So he is left with 88, and the total number of questions left is 98, because he has answered 2 questions. So the total number of questions is left is 98. So here we have got all the three probabilities. We can multiply them and get our answer. So this is 90 by 100 into 89 by 99 into 88 by 98. So if you want, you can leave the answer here only, but if you want, you can calculate this. This is a easy calculation which can be done very easily. You can cut 0 over here, 9 goes by 11, this goes again by 8. So here we have 89 into 8 divided by 10 into 98. So by 2, if we deduct this, we will get 49 over here. We have 2 again, this is 5. Okay, so this is not 100, this is only 10 because 1 0 is already been deducted. So here we have 89 into 2 divided by 49 into 5. So what is 89 into 2? We can easily calculate this, which will be 178, and 49 into 5 is also a very easy calculation which can be done, and we will get 245. So basically this is our answer to the question, that this is the probability that the student will pass the examination if he knows correct answer to 90 questions out of 100 questions. So we have got the answer to this question. Now let's move on to the second question. So here is our second question. It says, how many zeros are at the end of 1000 factorial? So first of all of us know what is 1000 factorial, which is written as 1000 into 999 into 998 into so on till 3 into 2 into 1. So you can check out, we have 1000 terms multiplied together, and this is not possible to multiply. So this is even not possible for a normal calculator to multiply of 1000 factorial. So only we need is how many zeros are at the end. So for this we need not calculate this, or we need not count each zero. What we need to do is follow a basic rule, a general formula we have for this, and that general formula is written as, we can write this as 1000, because we have 1000 factorial. Whenever we will have a factorial, we will follow this rule. What we have is 1000 divided by, what we will write is 5 to the power 1, then plus, then we will have 1000 divided by 5 to the power 2 plus 1000 divided by 5 to the power 3 plus 1000 divided by 5 to the power 4, and so on. And the question is, till where will this calculation go? And answer to this will be, we will continue going like this until the denominator gets higher than the numerator. As soon as the denominator gets higher than the numerator, we will stop at the term before that term. So here you can check, we have 1000 by 5. So obviously 5 is less than 1000. So we will consider this, which will give us 200, plus we have 1000 by 5 square, which is 25. So again this is smaller than that, so we will calculate 1000 by 25, which will give us 40, plus we will have 1000 by 5 cube, which is 125. So now let me tell one thing, in this we will have a basic, in this we will always consider the whole number, we will not consider the decimal points. That is, we will always, like here in this we have 1000 by 125. So if we calculate 1000 by 125, we will get the exact value as 8. So here you can see we have got 8, so we will directly write 8. But in the next, here you can check 1000 by 5 to the power 4. So what is 5 to the power 4? 5 to the power 4 is 625. So here we will write 1000 divided by 625. So now you can check, if we divide 1000 by 625, our answer will be 1.6. So here we must take 1.6, but no, here this is greatest integer function, and this represents that we will take the only the whole part, whole number part, we will ignore the decimal part. So 1000 by 625 will give only 1 and not 1.6. Now continuing, we will have 1000 divided by 5 to the power 5. So here you can check 1000 divided by 5 to the power. So what is 5 to the power 5? So 1000 divided by 5 to the power 5 is equal to 1000 divided by 3125. So this time you can check we have a denominator which is larger than numerator, so we will not consider 5 to the power 5, we will stop at 5 to the power 4. So basically you can check we have a equation here and we will calculate this, that is 200 plus 40 plus 8 plus 1, which gives 249. So this will be the answer. In this way we will calculate the total number of zeros. And how to this, the mechanism behind this is that in every zero, as you can check, if you multiply from 1 2 3 4 5 dot 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 10, and you can check over here that from how many zeros will we get in 10 factorial. In 10 factorial at the end, how many zeros we have? So first zero comes up when 2 gets multiplied with 5. So first comes up from 2 into 5 and the second comes up from 10. So basically we have two zeros in 10 factorial. So what are the source of it? One is 2, another one is 5 and another one is 10. So basically you can check over here that this is a multiplication 5 into 2, that is 10, and here also 10 we have, which is 5 into 2. So basically if we count the number of 5s and 2s together, we can count the number of zeros also. But here you can check we have divided it by 5 to the power 1 whole square whole cube whole 4. We can do this as 2 to the power also, but that will be a very huge problem. So considering 5, because in 10 also we have 5 into 2 and 5 into 2 also gives us 1 0. So we will consider 5 and we will divide it in this way. The number given divided by 5 to the power 1, 5 to the power 2, and the sum of that until the denominator gets higher than the numerator. And we will then add up all the numbers and we will get our answer, that is 249. So answer to this question is 249, that is 249 zeros are at the end of 1000 factorial. So 249, that is option number C. Hence option C is the correct answer. So this question seemed a very difficult one because we have a huge number 1000 factorial, but it can be solved in this very easy manner. Now let's move on to the third question. So here we have third question which says the product of first 100 positive integer ends with. So here also we have same thing, but here we have not used the factorial part, but it is product of first 100 positive integers. So first 100 positive integers are 1 into 2 into 3 dot 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 till 99 into 100. So these are the first 100 positive integers. So this can be written as 100 factorial. Simply 100 factorial we can write as in that we had 1000 factorial, in this we have 100 factorial. So we will follow the same rule here also. So here we will write 100 by 5 to the power 1 plus 100 by 5 square plus 100 by 5 cube dot dot dot. So now let's check. We have 100 by 5 plus we have 100 by 25 plus we have 100 by 125. So here you can check denominator is larger than numerator, so we will not consider this. We will end over here. So these two we will check out, and how 100 by 5 gives us 20. So this will be 20 over here. 100 divided by 5 is 20 plus 100 divided by 25 is 4. So this is the total number of zeros, which gives is 24. So total number of zeros will be 24, that is option number D. So this is a very easy method of counting the total number of zeros at the end of any number. Here we had 100 factorial, in previous question we had 1000 factorial, but we did it very easily. So I will like to end this video here. You will find some more advanced statistics questions in our further video.